Okay, testing, moving right along. I want to show you how simple this is. What I am doing is I'm continuing with the Ghpython nodes. So what I've done is I've gone from using this top stuff isn't important. It just brings in the X, Y, and the out and the A to start. But I'm not even using it anymore, so I don't think I even need that. The script, you can see how short this is. I've made it work in Rhino script syntax as RS, but I've decided to import as Rhino geometry as RG to deal with geometries and not GUIDs. And I'm importing math like I said I would. And I've taken that for I in range X. I decided to set as a parameter coming in right here as a slider I can set from 0 to 10. And number slider 6 in Y because I want to do a nested loop for J in range Y. And then I'm going to create those point, or P for points, at Rhino geometry at 3D point. And I'm, of course, playing with what I love so much, math sine at I and math cos at J. And then I have put the Z so I can get a loft by just putting I to the exponent J. And this is what's so wonderful to just start playing with this and thinking of your variables and remembering your old math classes and what you can do with it. So outside of just printing data, which is what's happening here, and it's a stream of what's happening, it's pretty boring if you look at it. It's not a Boolean. You couldn't use it as a Boolean. Well, you could use the first section as a Boolean, 0, 1, so that's something to keep your eye on. You're going to append B with P as you go and keep making that list a little longer, and then that list will generate a series of points that if I go in here, you'll see them, and there they are, and they have a really nice mathematical quality, and they're in 3 dimensions. I will turn the spinning off just so it's not so irritating, and I will take my view. I will take my visibility and turn this to invisible. And you see the points working in a raised fashion. I think it's nice to see the geometry that I made from it. It's just beautiful. It seems when I select it, you can see the 2 different colors, but let's just take that geometry and leave it off for now. Nice little construct just made by cylinders and a little bit of a script. How simple, a nested loop playing with the maths. It's infinite to what you want to do in there, and then I actually threw in, I took all these values down here and played with them as circles to start, and they have these nice patterns that you could do. You could project these to a plane, do a region union. You could start going in the grasshopper and playing with path mapper, and oh my gosh, you go into all the wonderful sets tools to knock them out and deal with trees. But we'll get the trees sooner or later in Rhino Common. Right now, just let me deal with single items and possibly lists. Then I produced cylinders on each one of those, and I capped each brep, and I thought that was enough. You've got your points that are related to it. And why did I bring that in? The C math, because C is going down here to the radius. I thought that would be interesting. Let me just control shift and see what these are actually going to. Oh, they're going to the radius of the circle and the radius of the cylinders. And I thought I'd throw that through a tangent function, just multiply I by j and divide it by y, because I've got all these incredible numbers. So as I'm playing with this, look at what I can do to this. I mean, I can balloon that right up and just explode it, but I can also just make it microscopically thin, take it down to almost nothing, which is very nice to think about that as a controlled geometry. Very hard to script in Grasshopper. I'd have a hard time playing with that geometrically in Grasshopper. Now, if you're thinking of using this as a sculpture, or using this as a type of function to create geometries, this is where it's going to explode, and in my opinion, just become very, very interesting. So, like I said, you can try and think like a mathematician to anticipate and predict what all this will do. But just write these scripts and have fun. The most basic of scripts create your geometries. And yes, they're kind of meaningful, but if the data driving this, if this data coming in from Excel sheets is creating an abstract sculpture, that's almost like a data visualization tool. And if you start doing those in many iterations with many different data, you could take this, and I really believe the future, oh, there's Hattie Odell. I believe the future is actually about being creative with this medium, the same way artists were creative with oxyacetylene tanks at the turn of the last century, aluminum, plastics, taking for medicine and dealing with his vinyls to make artwork out of throughout the 60s. Take clay from the beginning of time, plaster from the earliest Sumerian idols through Egyptian paste and all these wonderful gypsum products that can be used. Egyptian paste is a different thing with glass and silica. But I mean, you've got all these tools to be creative with. Why not jump into here? Look at that script in Python. It would not be hard. Obviously, to move from Rhino script syntax into Rhino geometry, and at this point start programming in C. And if you find a way to create some very interesting geometries that might be applied to all of the plugins and all of the apps that service food for Rhino, I don't see it's a far cry of wrapping your head around a very clear, concise, and cogent and intelligible plugin that people become obsessed about to play with. So it's been a long time coming over the last couple of years, but certainly this summer, that long time coming is becoming exponential, just like this piece of sculpture I made by simply multiplying or taking the exponent of I to j. 5 minutes into this, easy to script, easy to copy, infinite varieties of this if you want to go into it. But we will learn how to basically have Python. We'll apply it to a geometries through Rhino Common, and we'll use Rhino.geometries.rg, and we will script simple things, and with a little bit of knowledge of how to do CAD in Rhino and a little bit of pre-knowledge in Grasshopper, what to expect, I won't be jumping into these plugins. There's enough to do with math, sets, and vectors. Maybe some curves, maybe a few surface tools, a few intersections. But as we slowly learn more and more how to do it within the Python script editor, the less and less we have to take it outside of here. And you can see we have 37 milliseconds on this brep cap. I've got to find ways to keep it so my profiler never comes up red. I want everything running in under a millisecond. Thanks for watching. Onward and upward. And let's just perfect on the other form because it is a beauty. And yeah, I could make that into my house. I could live in that.